In a previous video, I explained when we use integrating factors and how to obtain them. So let's take a look at this equation that we have here. It has the shape of an exact equation, but let's check it. So in order to check it, we have to do the derivative of m with respect to y. Let's not forget m is the function that we multiply by dx. So the derivative is 4y minus 6x, and nx is the derivative of n is the function that we multiply by dy with respect to x, so we get 3y minus 8x. So obviously these two are not equal to each other, so the equation is not exact. So what do we do when the equation is not exact? Well, you guessed. We are going to use integrating factors. But for this particular problem, we know the shape of the integrating factor, but we need to find the exact factor. So find n and m such that x to the n, y to the m is an integrating factor. Of equation star, which will make the equation an exact equation. So this is what we're going to do. We're going to multiply equation star by x to the n, y to the m. So we get 2 x to the n, y to m plus 2, because we had the y to the m and then y to the second. So y to the m times y to the second, it's y to m plus 2. Minus 6x to n plus 1, y to m plus 1 dx, plus 3x to n plus 1, y to m plus 1, minus 4x to n plus 2, y to the m dy equals 0. And again, it's an integrating factor, so makes my equation exact. So I know that by multiplying by that, the equation is exact. The equation that we obtain, let's call it 2 stars, is exact. What does that mean? Well, it means we're going to use the exactness, the condition of exactness, to find n and m. So I'm going to work out the equation of exactness now. So my, again, now m, it's a new thing, is this one. So we're going to differentiate with respect to y. So you can pause the video and try it yourself. So it's 2x to the n, m plus 2, y to m plus 1, minus 6x to n plus 1 times m plus 1, y to the m. And n of x, the derivative of n with respect to x, which is the second function, this one, is 3n plus 1 x to n, y to m plus 1, minus 4n plus 2 x to n plus 1, y to the m. We know that these two equations must be equal to each other. So how do we do that? Well, if we compare them, this term x to the n, y to m plus 1, it's here as well. So in order for them to be equal to each other, their coefficients must be equal to each other. So the coefficients are 2m plus 2 must equal to 3 times n plus 1. So 2m plus 2 equals 3 to n plus 1. Because, again, the derivative of m with respect to y equals n with respect to x, the condition of exactness. And then the same thing for the next part. The term x to n plus 1, y to m, it's here as well. So their coefficients, negative 6 times n plus 1, must equal to negative 4 times n plus 2. So negative 6n plus 1 equals negative 4n plus 2. Luckily, you learned how to solve systems of two equations with two unknown values. So I'm going to rearrange them. So 2m minus 3n equals 3 minus 4. Negative 6m plus 4n equals negative 8 plus 6. So we get 2m minus 3n equals negative 1, and negative 6m plus 4n equals negative 2. We multiply by 3, and we get negative 5n equals negative 5, n equals 1. And I can replace anywhere I want, and I get 2m minus 3 equals negative 1, 2m equals 2, m equals 1, and we found both of them. So the integrating factor is x, y, because it was x to the n, y to the m. What does that do? It makes my equation exact. So basically, when you multiply the first equation star by x times y, so let's do that. When we multiply by x times y, we get 2xy to the second minus 6x squared y squared dx plus 3x squared y squared minus 4x cubed y dy equals 0. This will be is exact. And actually, you have an exact video with this exact equation that is gonna be here. I made a mistake. 2xy cubed. This equation is solved in another video. I hope this helps.